Hello everyone. Today I want us to look at 1-bit counter using the D-type flip-flop. And with 1-bit counter, this is how it's going to look at. This is up counter anyway, so it counts from 0 to 1. 1-bit counter will have just two states, that is 0 and 1. Or 1 and 0, because 2 to the power 1 is 2, so we will have two options or two states, that is 0 and 1. And that is what is going on now. So if you look at it, we have 0 1 0 1 0 1 0 1, and this is up counter. I want us to look at how we can do it. You can also use that 1-bit counter to toggle lights, so that the lights will be flashing as you see here. So I want us to first of all look at how you can build one for yourself. So I'm just deleting everything here. Well, I'll leave those resistors connected as they are. Now, what you need is the 7-segment decoder, which I have here. That is the 7-segment decoder, and then you have the 7-segment binary display. So this is the 7-segment decoder and the 7-segment binary display. Let me just extend and delete. So you need these components here, or these ICs here. Now what you have to do is, I've got this switch here. Actually, it's not a switch, it's a clock. Okay, that is the clock. So I've got this clock, and that's that one here, so I don't really need any more. What you have to do for up counter, what you do is you connect the D, or the input D, or the data to the not Q here, the inverse of the output. You connect it here, and then you connect the what is it called, the clock, to that one. And then the next thing is to connect the output. So on the decoder we have input for 4 outputs, but here I've got only 1 output because this is 1-bit counter and I'm using just 1D flip-flop. So I'll connect this to that. And then I'm going to connect this to that. So that's connected. And then I'll connect this bit here. It goes to the F. I'll connect it to F. So if we start it, always the D will have the input of the not Q output here, and it will be opposite of the output Q here. So let's see how this is going to do the counting, the up counting. Let's start the simulation. So 0 1 0 1. Actually, this will be of no use because it can only count up to from 0 up to 1, or maybe 2 counts, 0 and 1. So if we count it 1, so if we count the 0 as 1, then maybe the next one will be 2. So it's just 2 counts here, which is of no use actually. But how can we also, for example, let me stop the simulation for now. How can we also toggle lights using the flip-flop, or maybe the 1-bit flip-flop? So I can just delete that one here, and then I will connect this one. Sorry, forgive me. I'll connect the green to that, and then I'll connect the yellow to the NOT output, and let's see how the whole thing is going to toggle, how the light is going to toggle here. So you see the lights toggling. Okay, well, we can also connect the decoder to the output, and we will just count as usual. So this counts from 1 to 1 up. It counts up from 1 0 1 0. Now what I want us to do is, I'm just going to delete this, and I'll show you something here. I'm going to connect the output, this output here. Let me connect this, let me disconnect this line. I want to count down, so I'm going to, and if you want to count down, the output Q should be connected to the clock. So I'm going to count down, and I'll connect this to that. Let's see how this is going to work. Well, we're playing with it, and it should work anyway. So it's 1 0 1 0 1 0. So you have seen it, that if you want to count down to, this is how you can do it. Well, next video will center on 2-bit what is it called, 2-bit counter, and 2 to the power 2 is 4, so that will give us 4 states, or it will count from 0 up to 3. Do you see what I mean? 4 counts, so from 0 up to 3. We can also look at 3 bits, 4 bits, up and down counters, and so on. We will also look at traffic light, how we can use this to create traffic lights. Please do subscribe to my video and expect the next one coming. Thank you all.